everybody, this is Melanie Jaskell from the Samsung Developers Group, coming to you from our San Jose office again. Today, we're going to be covering LBS APIs, adding location functions to your application. So what does LBS stand for? Location-based services. The location-based service industry has actually changed a lot in the last 15 years, and a lot of the growth has happened because of some really cool milestones that have happened. Starting in 1996, there was the FCC mandate for E911, which basically made operators, or required operators, to be able to locate emergency callers through their cell phones. After that, in 2000, there was also the Location Interoperability Forum that was created, and that was a group of both operators and device manufacturers, as well as other industry players, that really wanted to define how the interaction between the network and the client would be around location. So one of the first protocols that they had standardized was the Mobile Location Protocol, MLP, and that really defined how location was interchanged between network providers as well as client providers such as devices. In 2002 then, JSR 179 was finalized, and that was the first time in the Java world that a third-party application had a standard way of obtaining a device's location. It really didn't do a lot other than that, but that was the reason that Location 2.0, the later JSR, was standardized. In 2004, Surfstar 3, which is a GPS platform, was also released into the market. And the main reason that that was a major milestone was because it really was a pretty big leap in GPS technology as far as what it could provide, the accuracy and the performance. And so based on this, it opened up a lot of doors as to what kind of use cases you could really accomplish using GPS. So it was not only then looked at for an E911, but after that it was also looked at for consumer-based applications. Then in 2006, the Google Maps API was released into the world. And then on top of that, JSR 293, which I mentioned before was Location 2.0, was also released. These APIs really allowed the application developer to not only get a current location from the device, but also then get maps, routing, geocoding, and a whole lot of other location-related services from a standard set of APIs. So the industry is really growing, and this has been kind of talked about for a really long time, but we really see a pretty big flux into the market now of location-enabled services. And the forecast is pretty high. There just was recently 2 studies in June that said that by 2015 or 2016, depending on the survey, the industry is going to hit $10 billion as far as revenue. So that's pretty exciting, and it's another reason that you might want to take a look at adding location to your application. So the key things that we'll be covering in this session, the first is going to be basically how do you get a current location? How do you get the device's current location? Then the second is going to be how you can actually use the Google Maps API extension to then get additional capabilities around once you've gotten a current location. So there's a lot of different things that you can use location for. At this point, location is really a context that you can add to almost every application. And you see a lot of different use cases in the market today. One of them is just being able to plot a point on a map. And then another really common one is getting navigation or directions to a certain point or point of interest. You can also find local things around you, nearest ATM, closest restaurants, the coolest bars. And then for the enterprise, there's a lot of location that's used for vehicle and asset tracking and management. You can do local weather automatically with location, coupons for those of you who are really into shopping, and then location-based gaming. And the list just keeps going on. And this is, again, because location can be used as a context for almost every application out there. So a lot of people are incorporating it to add another dimension to their applications. So how does location work on the Android platform? The Android platform provides a location framework, and it really allows you to get the device's current location and bearing, and then you can also then register for updates. And the way that Android actually obtains the location is a combination of a GPS or standalone GPS, and then some other network-based methods. So this can be cell tower or Wi-Fi, and also even between GPS and network-based location, you can choose to use one, the other, or both. So location capabilities then on each device, though, are going to be dependent on what's available on the device as well as what network capabilities you have at the time that you're requesting a location. As I mentioned, there's two major categories of the location provider. One is GPS, the other is going to be the network location provider. Now there's pros and cons to using both or one or the other. GPS is the most accurate of the positioning methods, but it uses satellites to determine your location. So that means if you don't have a direct line of sight into the sky, you won't be able to see satellites, which means you can't actually find your location. So this means that the big concern about using GPS only is that you really won't have a location typically when you're in an indoor environment. Then the other concern is that there is battery consumption that's associated with using GPS. And then finally, one of the other drawbacks is when you do use standalone GPS, which means that you're not getting some sort of point of reference as far as where you're located from the network, whether that's Wi-Fi or cell tower, it does sometimes take a very long time to get that initial fix. Now, from a network location provider, that's the other main category, there's less accurate positioning. So the tough part with network positioning is that if you're looking to have a really good user experience, and that user experience is based on having a very good idea of where the device is at the time, this is probably not going to work out for you. So the other issue is that Wi-Fi APIs and cell towers do sometimes change, and depending on where you are in the world, it will change more frequently. But the cool thing about network location is it can be used indoors because the technologies that it's based on, cell tower and Wi-Fi, do penetrate indoor. And then the other good, definitely good thing about using network location is that you can get a much faster initial fix. So how do you get a current location? In Android, you're going to be using the location manager, and there'll be a callback function that you're going to define. So you need to implement the location listener, and what happens is when you call the request location update, you'll pass your location listener that you've implemented. Now, at this point, you can define whether you want to use GPS or the network location provider, or you can not specify it, and then it would use a combination of both or whatever is available that would meet your criteria. So the location manager will then use your callback methods that were implemented in the location listener. And this will happen when a location is either changed or the status of the location's service has changed. So some tips for improving performance are really getting the last known location before you're waiting for your final location. So a lot of the times when you're waiting for that first fix, it's helpful to just show something on a map or to have some sort of concept as to where you are. And you can do that with the Get Last Known Location API. The other thing that you can do is use the min time and min distance parameters to really define exactly how often you want to be updated. And the reason that this is going to affect your performance is because depending on how often you need to be updated or how accurately the fix needs to be, you will need to change the value. And these are going to be in milliseconds. So if you're saying that you want this to be set at 0, both of these to be set at 0, the location manager will update you as often as it possibly can. But that then leads to a trade-off in battery power as well as processing power. So in order to get GPS or network location, you do need to request permission. And there's two permissions that are available for you to declare in your manifest file. One of them is going to be access course location. And this is what you need in order to get a network location provider to work for you and to return some sort of location based on either cell tower or Wi-Fi. And this is going to then trigger a user permission request, as you know. Then the other permission is the access find location, and this will get you access to both the GPS as well as network location. So it covers both of them. So if you've requested find location, you don't have to request course location as well. Now, if you don't have either one of these permissions granted, then what happens is the application will fail at runtime when you try to get the device's current location. And then you can just take a look really quickly at the sample of the manifest file. But this is an example of how you can request access find location. The other cool thing that the Android platform does for you is provide you a mechanism to test locations and inject locations when you don't have a device. So the Android emulator has three ways of injecting location data. One of them is through Eclipse. Eclipse will take a GPX or an XML file. DDMS is the second way. It will also take a GPX or XML file. And then finally, you can also use the geo command in the emulator command console. And that takes a single location. So it'll take a latitude, longitude, and an altitude coordinate, or it'll take an NMEA sentence. So now that we've learned how to get a device's current location, you really want to know what you can do with it on the Android platform. So in the Android platform, there's the com.google.android.maps package. And this is an external library. So what does that mean? That means it really doesn't come with the standard Android platform. It's an optional package that may not be available on all Android compliant devices. There's also an add-on that you'll have to plug into your SDK in order to use and build and test your applications if you do decide to use these APIs. The key classes in this package are GeoPoint, which is a point in space. It's a pair of latitude and longitude coordinates. The next one is MapView. And this is the main class that you're going to be using for displaying and manipulating maps. It has built-in capabilities for both panning and zooming, and what's cool is it has a lot of the UI functions that you usually associate with maps already part of the package. So it'll handle network requests for when you need additional tiles, for when you're panning or zooming and you need to download different tiles. It also has support for then satellite, traffic, and then street views. Another class that's really important in this class, or in this package, is the overlay class, and that is going to allow you to overlay something on top of the map itself. So there's a lot more functionality that's in this package, but those are the main classes. So how do you use the Google Maps API? There's actually a very simple process that you can go through to incorporate these type of APIs into your application. The first is you'll have to add the Maps add-on to your Google Android project. There's multiple versions that are available, and they're dependent on the API level that you're building for. So just make sure that when you're downloading the add-on, you're downloading the appropriate one for the API level. Then the next thing that you need to do is in the manifest file, you'll need to add the uses library tag with com.google.android.maps. And the next step is then just getting an API key. So the API key is really going to be what allows you to access a lot of the server-side data. So you'll need to get that. And then finally, you need to sign the application with the certificate that is associated with your Maps API key. So I want to go into a little bit more detail on how you can get an API key because it is pretty crucial to the process. The first thing you really need to do is then register with the Google Maps service, and this includes agreeing to then a terms of service agreement. And you can find that at the website that I have right here. and it's really long, so I'm not going to read it. I wish there was a shorter version of it, but you can just find that through Android, the Android developer website as well. It's a two-part process. The first is really registering your MD5 fingerprint of the certificate that you're planning on signing your application with the on the website that will then give you the Maps API key. Then the second is to then add a reference to that key within each map view. So you can do that either in XML or you can instantiate it directly from your code. The same key, the cool thing is the same key can actually be used across multiple applications. So that means as long as you're signing it with the same certificate, you'll be able to use the exact same key rather than having to re-register or reapply for different keys for different applications. So that kind of gives you a basic understanding of how you can do location-based services on the Android platform. If you have additional questions, as always, feel free to contact your local Samsung developers representative. Thanks. Bye-bye.